Greetings and salutations, everybody. This is Jacob. Okay, so how the heck do we go about conquering this conundrum? To say it looks bewildering is the understatement of the century. I can't make heads or tails of it, you see. Worry not, my friends. I'll walk you through this problem like there's no tomorrow. Rest assured, no one will leave this video scratching their heads or rubbing their chins. Oh no, not on my watch. So let's get this show on the road, shall we? Okay, so let's start attacking this problem from the funky chords first. We're going to have to figure out the y component and the x component of the distance BE. We do that by adding up the horizontal and vertical sides of these three right triangles here, BCC prime, CDD prime, and DEE prime. Let's start with BCC prime. Since this angle here is 84 degrees and AB is vertical, meaning it's perpendicular to the floor, and this angle here is 6 degrees, we'll call the horizontal side of this triangle x1 and the vertical side y1. So from trigonometry, we have x1 equals 7 times cosine of 6 equals 6.96, and y1 equals 7 times sine of 6 degrees equals 0.73. Now let's go to the second triangle, CDD prime. Since this angle here is 95.8 degrees, and this one is 84, and this angle here is 95.8 minus 84 equals 11.8 degrees. So x2 equals 4 times sine of 11.8, which is 0.817, and y2 equals 3.915. Moving on to the third right triangle, DEE prime. Okay, this angle here from CDD prime is 90 minus 11.8 equals 78.2 degrees. And since this angle here is 112 degrees, and this one is 90 degrees, and this whole angle here is 90 plus 78.2 plus 112 equals 280.2. And this angle here is 360 minus 280.2 equals 79.8. Hence, x3 equals 4 times sine of 79.8, which is 3.936. And y3 equals 4 times cosine of 79.8, which is 0.708. Now we add up the vertical and the horizontal distances to get the length of this half chord here, which we'll call EG. So the y distance of EG from B is y2 plus y3 minus y1, which is 3.893. And the length of EG is x1 plus x2 plus x3, which is 11.713. Now we'll calculate the length of the chord AE. Since BG is 3.893 and AG is 3 plus 3.893, which is 6.893, and EG is, as we said, 11.713, and AE is, from the Pythagorean theorem, square root of 6.893 squared plus 11.913 squared equals 13.59. Okay, now let's calculate the chord AF. Since this angle here is 84 degrees and this one is 66.1, then the total angle is 150.1 degrees. So we'll use the law of cosines to find AF. We plug in our numbers in our law of cosines formula and we get AF equals 14.677. Now we have to figure out where the half chord EG intersects AF. We'll call the point of intersection H. First we have to find this angle here. We'll use the law of sines. So we have sine of BAF over 12 equals sine of 150.1 over 14.677, and we end up with 0.407. So the angle BAF is arc sine of 0.407, which is 24 degrees. Now we turn our attention to the triangle AGH, and we calculate GH using the law of sines again. And since this angle here is 90 minus 24 equals 66, so now we have sine of 24 over GH equals sine of 66 over 6.893, and we end up with GH equals 3.068. And AH from the Pythagorean theorem is square root of 3.068 squared plus 6.893 squared, which is 7.544. And HF is 14.677 minus 7.544, which is 7.133. And EH is 11.713 minus 3.068, which is 8.645. So we found AH, HF, and EH. So now what do we do? How does the half chord help us, you ask? What was the point of all this? Worry not, my friends. It's all gonna become clear as day. You have me here clearing out the weeds, remember? Oh yes. So now we bring out the big guns. In a war, when everything seems hopeless, you take out your big guns and you blow everyone to kingdom come. Oh yes. So without further ado, making its debut on this channel, the intersecting chords theorem. Oh yes. The intersecting chords theorem states that if two chords in a circle intersect at some point, then the product of the partitions are equal. That is, if two chords AB and CD intersect at E, then AE times EB equals CE times ED. So we take that and apply it to our physical situation here. We're going to complete this half chord that we have, make it into a full chord. We're going to find this line segment HI. So AH times HF equals EH times HI, which is AI equals 6.224. And so the full chord EI is EI equals HI plus EH, which is 14.869. Okay, so now we have to find this angle here, AEG, before proceeding any further, using the triangle AEG. So we have cosine of AEG equals 11.713 over 13.59, which is 0.861. So AEG is our cosine of 0.861, which is 30.57 degrees. So now we turn our attention to the bigger triangle, AEI. Now we find the side AI using the law of cosines. So we have AI equals 7.603. Okay, so now we have an angle from the circumference looking at a full chord. Now we can use a double angle theorem to find the radius of the circle. The double angle theorem states that an angle that looks at a chord from the circumference is half the angle that emanates from the center of the circle. So the central angle, theta, that looks at the chord AI is 2 times 30.57, which is 61.14 degrees. So now we use the length of a chord formula to find the radius of the circle, which is 2r times sine of theta over 2 equals AI, which is 2 times r times sine of 30.57 equals 7.603. And we solve for r and we get 7.474. So now we found the radius of the circle. Now we have to find the central angle that looks at the chord AE. We use the length of a chord formula again, and we have 2 times 7.474 times sine of theta over 2 equals 13.59. And we solve for theta, and we end up with theta equals 130.73 degrees. We're on the last stretch, my friends. Please bear with me. Now we have to find the area of these three triangles here. We'll call them ABJ, CJK, and DEK. And the area of this circle segment that's enclosed by the chord AE, which is the easy part. In order to find the total area of this irregular shape, the shaded region, which is what the problem is asking us to find, first we have to find where the chord AE intersects BC and CD. Let's work out ABJ first. Since this angle here is 30.57 and this one is 90 minus 30.57 equals 59.43, using the bigger triangle AEG, and since this angle here is 84 degrees, then the remaining angle is 180 minus 84 minus 59.43 equals 36.57 degrees. Now we use the law of sines again to find BJ and AJ. So we have sine of 59.43 for BJ equals sine of 36.57 over 3. And we solve for BJ and we get 4.335. Likewise, we use the law of sines to find AJ, and we end up with AJ equals 5. Moving on to the triangle CJK. Since this angle here is 95.8, this one is 36.57, and this one is 180 minus 95.8 minus 36.57, which is 47.63. And CJ is 7 minus BJ, which is 7 minus 4.335, which is 2.665. And CK is, from the law of sines again, 2.149. And JK is 3.58. Moving on to EDK. EK is just AE minus JK minus AJ, which is 13.59 minus 5 minus 3.58, which is 5.01. ED is 4 from our initial conditions, and DK is 4 minus 2.149, which is 1.851. Okay, so now we're prepared to calculate the area of these three triangles and the area of the circle segment that's enclosed by the chord AE. To calculate the area of the triangles, we'll be using Heron's formula, which is as you see here, which is the square root of s times s minus a times s minus b times s minus c, where a and b and c are the sides of the triangle, and s is a plus b plus c over 2. We'll start with ABJ, and the area of ABJ using this formula is 6.461. CJK is 2.85, and EDK is 3.416. And the area of a circle segment is given by this formula here. So we plug in our numbers to get the area of our desired circle segment, and we get area of circle segment enclosed by AE equals 42.565. So now we're ready to find the total area of the shaded region, which is total area equals area of ABJ minus area of CJK plus area of EDK plus area of the circle segment. We subtract the area of the triangle CJK from our final result because it's already included in the circle segment. So we have to subtract it from our final result because it's not in the shaded region. So our final result is 6.461 minus 2.85 plus 3.416 plus 42.565, which is a grand total of 49.586 units squared. And we'll round that up to 49.6, our final result. So that's all she wrote, my friends. That's your answer. 49.6. Intuitive answer or out of left field? Let me know in the comments. So that was a fun geometry puzzle, wasn't it? It was quite a vigorous one. It gave us quite a workout, but in the end we prevailed. We got the job done. Oh yes. Please forgive me for the ugly non-integer initial conditions. Some of the angles were fractional. That's because I used an actual circle in software to come up with the initial chord lengths and angles. I couldn't just pull out numbers from my own behind, or else I'd be flirting with contradictions all over the place, my friends. Chords are quite tricky beasts. You have to draw things to scale. If you start out with the erroneous initial conditions, then you'll end up with erroneous answers, my friends. Garbage in, garbage out, as the programmers say. Oh yes. So the fractional numbers were a necessary evil, unfortunately. So let me know in the comments if you liked this puzzle, if you found it difficult, if you solved it another way. As always, keep those suggestions coming, my friends. Smash those buttons like there's no tomorrow. And I'll see you guys in the next video. Bye-bye.